Hydraulics and pneumatics. Directional control valves. Presented by Dr. Albutrabi. Directional control devices. Directional control devices allow a system operator to control the direction of fluid flow in the system. Starting and stopping of actuators. Control of actuator movement direction. Directional control devices. Directional control devices can be grouped in 4 general classifications. Shut-off or two-way valves. Check valves. Three-way valves. Four-way valves. Directional control devices. The primary purpose of shut-off valves is to block fluid flow through a hydraulic system line. Globe valve. Gate valve. Ball valve. Spool valve. Needle valve. Directional control devices. Typical globe valve. Directional control devices. Typical gate valve. Directional control devices. Typical ball valve. Directional control devices. Typical spool valve. Directional control devices. Typical needle valve. Directional control devices. The primary purpose of check valves is to allow free flow in one direction while preventing reverse flow. Other functions include bypassing components during the return cycle of the system, providing flow resistance to maintain a minimum system pressure required for pilot operations. Directional control devices. Typical inline check valve. Directional control devices. Typical right-angle check valve. Directional control devices. A standard check valve consists of a valve body containing a one-way valve located between inlet and outlet ports. The one-way valve allows fluid flow through the valve in only one direction. Some designs contain a spring that seats the valve poppet or ball. In other designs, the poppet is seated only by fluid flow. Directional control devices. Restriction check valves allow free flow in one direction and restricted flow when flow direction is reversed. This is accomplished via a metering orifice machined into the poppet. Typical restriction check valve. Directional control devices. Pilot-operated check valves can allow reverse flow through the valve. Typically, pilot pressure opens the valve. In some designs, pilot pressure may also hold the valve shut to block flow in both directions. Pilot pressure to open check valve. Directional control devices. Pilot pressure to block flow through valve. Directional control devices. Three-way directional control valves provide a means to extend rams and single-acting cylinders. The actuator is returned to its original position by an external force. System load. Spring built into the actuator. Directional control devices. Typical three-way directional control valve. Directional control devices. During extension, the three-way valve connects the actuator inlet line to a system supply line, allowing fluid to enter and extend the unit. During retraction, the valve blocks the supply line and connects the actuator line to a system return line, allowing external force to return the actuator to its original position while directing displaced fluid to the reservoir. Directional control devices. Four-way directional control valves provide a means to power actuators in either direction. Valve has 4 external ports for connection to system supply line, reservoir, and inlet and outlet of the actuator. Internal structure of the valve allows the ports to be alternately connected when a change in actuator direction is necessary. Directional control devices. Four-way valve powers double-acting cylinder during extension and retraction. Directional control devices. Four-way directional control valves are typically manufactured as 2 or 3 position valves. This provides several operating options when designing circuits. Typical 2-position, 4-way valve, 4/2-way valve. Directional control devices. In 2-position valves, the first position operates the actuator in one direction, while the second position reverses the direction. In 3-position valves, a center position is added that provides additional circuit operating characteristics. Directional control devices. Typical 3-position, 4-way valve. Directional control devices. A number of center position configurations are available. Closed, open, tandem, floating, regenerative. Directional control devices. Symbols for 4-way valve center position. Directional control devices. The center position affects directional control characteristics and overall system efficiency. Each style provides distinct operating characteristics that allow hydraulic system designers to obtain maximum performance from a system. Directional control devices. A number of activation methods are used to shift the internal components of directional control valves. 5 general categories: flow actuation, manual operation, mechanical operation, pilot operation, electrical operation. Flow actuation uses internal fluid movement to actuate the valve. No external mechanism or force is used. Directional control devices. Manual operation methods include hand wheels, levers, push buttons, foot pedals. These devices require constant operator presence and are typically found in less complex systems. Directional control devices. Mechanical operation methods include rollers, cams, levers, rams. Mechanical operation is often used when the opening and closing of the valve must occur at a specific position in actuator travel. Directional control devices. Circuit containing a mechanically actuated directional control valve. Directional control devices. Pilot operation uses system pressure to activate the valve, rather than physical labor. This method is effective when larger forces are needed to shift the valve. Remote operation is required because of safety or tight physical factors. Directional control devices. Electrical control of hydraulic systems is common in many types of equipment. Simple solenoid devices to shift basic valves. Electronic controllers operate proportional solenoid valves to produce extreme accuracy and repeatability. Directional control devices. Multiple position directional control valve may be held in a desired position using springs or detents. Springs are located on the ends of the valve spool to return the valve to its normal operating position. Directional control devices. Symbols for spring return valves. Directional control devices. Detents are locking devices that hold the spool in a selected position. The spool may be held until the operator manually shifts the valve. Increased system pressure at the end of an operation may automatically shift detent valves back to the normal position. Directional control devices. Typical detent operation.